Hello, students. Today we will discuss Newton-Raphson method. Okay, we will go through these contents the week starting from 5th of October till 9th of October. Okay, so we will have different lecture days, right? So we can discuss it during the lecture, or you can watch the video and then you can come well prepared to the online lecture. All right. So now let me tell you about the Newton-Raphson method. This is an open method. The previous method that we learned were closed methods. This method, Newton-Raphson method, is an open method. One initial condition will be given to you, function will be given to you. You can see here the graph of the function. Most important thing about Newton-Raphson method is that the function's derivative must be known, right? So for example, a polynomial is given to you, you can find its derivative very easily, okay? And of course, for the trigonometric functions as well. So now we need function, its derivative, and the initial condition. These three things must be given to you, or at least function and the initial condition, and the derivative you can obtain by yourself. Okay, and now the motivation behind the Newton-Raphson method is using the slope formula. Okay, let me take you to the formula here. You can see that xi plus 1 is equal to xi minus f of xi divided by f dash of xi. F and f dash, these are the function and the derivative, corresponding derivative. Now what is xi? Xi stands for the index. I stands for the index. All right, and we will use the index again and again during this semester, so please be informed that, for example, if I've asked you to find 3 iterations, this means that if x1 is given to you, you will give me x2, x3, x4. All right, so I plus 1 stands for the index. I stands for the index. In this formula, if I substitute I is equal to 1, what will happen? On the left hand side, I will have x2. On the right hand side, I will have x1 minus f of x1 divided by f dash of x1. All right, so such formula are called iterative or iterative formula, right? So now the question is that how to implement this algorithm on the given problem. So to understand it, let us go through a solved example. Now I have a function f of x. Please bring your notebook, pen and calculator and solve it side by side, okay? Function is given to you, minus 0.9x square plus 1.7x plus 2.5. Initial condition is given to you. I am using the index 1. Why? Because we can also use the same questions for the MATLAB algorithms, and the softwares, they always use the index from 1, not from 0. So for that good reason, I have started with the index 1. x1 is given to you, which is 5. Okay, now the question is that let us say that this is an exam type question, so I've asked you to perform 3 iterations. By this I mean to say give me x2, x3, x4. So now what is the first step? Let us go through the lecture step by step. Now you can see what is the first step. Find the derivative of the given function. Now the derivative is 2 times 0.9 x plus 1.7, and 2.5 derivative is 0. So you have minus 1.8 x plus 1.7. Okay, now you will use the index notation. Now you can see that f of x was given to you in this form. Now I am using the indices I. Okay, similarly, f dash of x is given to you in this form. I'm using the indices I. Okay, this is the most important thing. Now I will substitute these values in the formula. Now the formula will be given to you, and I believe that if with practice you'll be able to memorize the formula. Okay, xi plus 1. So it is better that you memorize the formula. Xi plus 1 is equal to xi minus f of xi divided by f dash of xi, and we can derive this formula from the slope formula. Okay, now what will happen next, students? You will substitute here the index I is equal to 1. Okay, I want to zoom it, so let me save a PDF document. Right, so now let me zoom it so that you'll be able to read it easily. Now this is the formula given to you called the Newton-Raphson formula. Function will change with every question. Okay, for this question, function was given to you. You substituted the index I with every x, and you have substituted f of x value here in the numerator, f dash of x value in the denominator. Now your formula is ready to use. Xi plus 1 is equal to xi minus f of xi divided by f dash of xi. Put in this equation I is equal to 1. What will happen? Here on the left hand side, you will get x2 is equal to x1 minus f of x1 divided by f dash of x1. And x1 will be given to you. Okay, so with the help of x1, you can obtain x2 with the help of the formula. Substitute here x1. Okay, so now in this formula, when you put x1 is equal to 5, what will happen? You will substitute x1 is equal to 5 in the right hand side, and you will get x2. That's great. So now from x1 and the Newton-Raphson formula, you have obtained x2. From x2 and the Newton-Raphson formula, you will obtain x3 and so on. You can see approximate relative error. In this question, I have not given you the exact answer. So you will not go for the exact error analysis. Okay, so true relative analysis, you will not go for that. You will go for the approximate relative error. What will happen? You will consider the two consecutive iterations. For example, x1 is 5, x2 is 3.424658. So you will say current minus previous divided by current absolute times 100%. Error is too high, 46% error is too big. Let us go to the next iteration. Now in the same formula, put I is equal to 2. What will happen? You will get a formula for x3. Here on the right hand side, you will substitute the values for x2 in the formula. Let me show you the formula here. Here is the formula. Here, when you substitute I is equal to 2, what will happen? You will get x3 is equal to x2 minus 0.9 x2 square plus 1.7 x2 plus 2.5 divided by and so on. Okay, so now from x2 you will obtain x3. So from x3 you will obtain x4. From x95 you will be able to obtain x96, and the process continues. But here you can see that after few iterations I've got 0 error. This means that now I have got the repeated root. So this is a sign that my calculations have reached the actual answer. So you can see that here 2.8601, 2.8601, this is converging to the actual answer, right? So this is the good point. This is the good news, right? So now this is the homework for you. A function is given to you, and the initial condition is given to you 3, and you will only perform 3 iterations and then make a table and upload it on portal 8th of October, which is too far from today. So you have got 8 to 9 days. All right. So good luck and hope to see you soon. Okay.